Hi guys, folks, how you doing? Thank you for braving 9 o'clock on Tuesday morning after the first night out of Dreamforce. Hopefully you're not all too hungover. I'm not, I promise. I know Hillary's going on as well, and that's probably a lot more interesting than listening to me whine on about development, but again, thank you for being here. So we're going to have a look at some kind of more advanced techniques for development on Force.com and Heroku. Hopefully you've all got some experience of the platform, so at least some kind of setup experience, point and click, understanding how to create objects. Hopefully you've all got a little bit of coding experience already. You kind of know what Apex is and Visualforce. Is that right? Kind of quick show of hands, Apex, Visualforce? We all had to go before? Excellent. JavaScript? Heroku? A little bit. Node? Okay, that's going to be exciting then. We're going to do some Node. Okay, we'll do that a little bit later on. The way this is set up, it's supposed to be 15 minutes or thereabouts of me talking, then 15 minutes of you guys kind of doing stuff. I'm going to try and do less talking and you do more work, because I personally think that you learn better when you're doing stuff, and I can come around and help you, and some of the other guys can as well. So I'm going to try not to whinge on too much, and we'll just get straight onto the exercises as quickly as possible. My name's Simon Goodyear. It's my beautiful picture up there. I run a small ISV based over in the UK, concentrating on building integrations between Salesforce and third-party services and a little bit of consulting work. I'm an advanced developer on Force.com MVP, and I've been doing this for, I don't know, 6 or so years, something like that. It's my job. I do this every day, so hopefully I should be able to answer your questions. If I can't, then I probably need to get a new job. We live in the social world, everybody likes social, so these are all the different ways you can connect to Salesforce developers. Twitter, Facebook, LinkedIn, YouTube, even Google+, if anybody uses Google+. It's a great way to get help. The community is very powerful. I mean, if you guys have done some development work, you probably know this already. The Salesforce and Force.com community is really powerful, very helpful. At Salesforce Devs, if you ever get stuck on Twitter, hashtag AskForce is always really good. The Stack Exchange as well, if you've not been there, then that's a really good place to get questions answered too. But we love helping people and trying to encourage more people to become developers in the community, and it's the only way we can do it is by supporting everybody else. So, what are we going to actually do today? We're going to have a look at these things here. We're going to have a look at JavaScript and Visualforce pages and how that actually hangs together, how you can make use of JavaScript and Visualforce pages, and the various different ways. There are lots of different options, or 3 different options. They've all got pros and cons, so we'll have a look at that and try and get a quick understanding of which one to use where. We'll have a quick look at the Salesforce1 Platform APIs, so actually making use of the APIs that Salesforce provide on the platform. How do we access those from external services? How do we authenticate? How do we pull data back? How do we visualize that? We're going to have a look at static resources, which I'm sure you've all seen before, but we're doing a lot of JavaScript. How can we package this up elsewhere? So static resources will go into that. And then we'll get into the Heroku and the Node stuff through Canvas. Canvas is pretty unutilized, I think, personally. So we'll have a look at Canvas and kind of some of the use cases around that and how to get going with that. This is only a 2.5-hour session. I think we've probably got 4 hours worth of content. So unfortunately, we have to maybe not get to unit testing, which upsets me a little bit because I think it's really important. And batching and scheduling, which is an advanced technique, but probably not as important. So once you've got the workbook, feel free to go home and carry on with this. If you've got any questions as you're doing it, if we don't get to covering these off, then stick them in the chat group or ping me on Twitter, and I'll be more than happy to answer the questions as you go through them in your own time. Because obviously you will all go through them in your own time, I do understand that. Has everybody signed up for a fresh, clean Salesforce Developer org? Yeah, can I see hands? Yes? It is a clean org. You must have a clean org. Don't try and do this in a production org. Don't try and do this in an existing sandbox. Please go to developers.salesforce.com, click the sign up button in the top right corner. You can be doing it now, because it's going to take a while to spin up all the orgs while everybody in Dreamforce is doing exactly the same thing as you. So please do that, because you're going to need it for the first lab in about 4 minutes' time. So I can't emphasize enough, it's got to be a clean org, otherwise things start going horribly wrong. Even if you've done the workshop before this that builds on this one, don't use that. So let's start fresh. We'll install a package to get you up to speed. So there's, obviously, you notice there's no workbook on your desk. That's because this is where the workbook is. So if you follow this bit.ly link, df14-intermediate-dev-workshop, it should take you to a GitHub page by Christoph. And this has got the workbook in, and these are the labs that you'll be doing. So if everybody could navigate to that now, make sure we catch up on that. I mean, I'll be able to ping this back up later, but... And I presume you've all managed to connect to the internet as well, haven't you? Obviously, that's kind of a prerequisite. And if at any point I'm going too fast or mumbling, I do understand I have a funny accent, so just put your hand up and say, and I'll try and change the way I talk. Okay, so hopefully you've all got that. If not, I'll bring it back up a bit later on, but let's just push on. We're going to have a quick recap of what the platform is. You're all here on an intermediate course, so I'm guessing you probably all know what the platform's about anyway, so we won't spend too long on this. But it empowers you as developers to do the fun stuff. That's how I look at it. You have an idea, and you often have to do these 1, 2, 3, 4, 5, 6 boring steps beforehand. Buy hardware, install complex software, make sure all your jars are in the right place, and define user access, and set up reporting, and think about security, and it goes on and on and on. And 6 months later, if you're lucky, everybody else has finished doing their job, and you can actually get on and do yours, and you can do the fun, but you can build your application. Salesforce, they take all that problem away from you. They give us a platform to do this on. They do all of that other stuff. It's there. You know, when you've just gone in and signed up for an org now, they've done all of that. It's provisioned. You get all of that for free, out of the box. You get a mobile application. You get all the security. You get the scalability. It's done. You can just get on and write code. And that's what we all want to do. We're developers. We like writing code. We like solving problems. It's the fun bit. This other stuff kind of gets in the way. So Salesforce1 is a platform. It's not just a CRM. It has lots of these pieces. This is the picture that you've all seen 1,000 times. It tells us kind of what we get. So we get Force.com, which is where we can build native apps that interact directly with our data in the Salesforce database. We have Heroku, which allows us to build public-facing websites that integrate back to Salesforce in a multitude of languages. It's a polyglot system. You can write in a lot of different languages on there. And then we have Exact Target, which allows you to manage your email and your marketing and your interaction with your customer. And Salesforce, at Dreamforce last year, they went on a lot about API first. So they've now got a layer of APIs across everything. There is no feature released in Salesforce anymore that does not have an API. They have to have an API first. Then on top of that, we've got the Salesforce1 app, which gives us mobile very quickly, but that is built upon the Salesforce1 Platform APIs, the same APIs that we'll be using. And then we have these bits across the top, and this is where we fit in. You've got Sales Cloud, Service Cloud, Marketing Cloud. We all know about those ones. App Exchange, that's where I spend a lot of my time building applications. Customer apps and partner apps. Custom apps and partner apps. So custom apps is where we're going to fit in. We're going to leverage the power of everything below us to build a custom application. So we get all of this for free. We get a mobile application. We get the ability to write across a multitude of different languages and interact with our data. And just makes everything consolidated and make sure everything behaves in the same way. It's a lot easier than trying to enforce that at an enterprise level through coding standards and libraries and all this kind of stuff. Well, the platform's there and it does it all for you. So, we talked about the kind of technologies we're going to look at. This is the use case we're going to have. We're going to build a conference app, given that we're a conference. It's going to have sessions and speakers and locations, pretty much what Salesforce used to manage Dreamforce. I say it builds upon the earlier workshop, so all the point-and-click stuff, but we've got a package that we can install shortly. It's the first lab that gets us all up to speed on that. And then we're going to do some interesting stuff. We're going to build a Google Maps integration, JavaScript. So this is JavaScript in Visualforce now. We're going to use that to understand how we can do those kind of things and pull data back. And we're going to create a companion application, something that sits on Heroku that people can, you know, a bit like your, who's downloaded the Dreamforce app? That's a companion application. It's pulling data out of Salesforce, but it's hosted elsewhere. So we'll have a look at how we host that in Heroku and pull the data from Salesforce. Then we're going to do the same thing again, but in Visualforce, just to kind of highlight a couple of techniques around there, around authentication and not needing to, and touch on static resources too. And then we'll get to the Node.js. So we'll build a special app out on Node.js, out on Heroku, and then we'll surface that using Canvas. Without any authentication, it's all handled for us, and we'll surface that in Salesforce. So it's an app running out on Heroku being surfaced in Salesforce. Just to remind you, everybody signed up for a developer org now? Yes? Brilliant. If you haven't, here's the URL again. They hammer us on this one. Make sure everybody signs up for a clean org, otherwise it doesn't work. So it's in the slides a lot. Okay, so we're going to have a look at JavaScript in Visualforce pages. Why would we use JavaScript in a Visualforce page? Visualforce is pretty good. It displays all the data for us. Anybody got any thoughts why we might want to use JavaScript? Kind of says it up there, I guess. Can anybody read my slide? That's what I've just asked. It's not a great question, is it? It gives us a much richer experience. JavaScript runs client-side, so it's a lot faster. If you've got to continually call back to the server and come back to do these nice little nuanced user interfaces, it's never going to work. It's slow and it's clunky. 9 times out of 10, when somebody does something on a page, we don't need to get any more data from the server. We just need to change how it's rendered. And JavaScript lets us do that really, really quickly. It lets us manipulate the DOM. We build whole applications in JavaScript if we wanted to. Apparently, some people do. But it's what gives us a very fast and responsive application. So it's become pretty powerful, JavaScript. It's a slightly different way of thinking. When you're doing this and you're thinking in kind of Apex and JavaScript at the same time, you've got to kind of get your head around 2 different programming models. But it's there, and it's very powerful. And I've just spent a long time, the past probably 3 months, building an AngularJS app that uses JavaScript Remoting, which we'll see in a minute, to pull data in. And it's very, very powerful. The app, it flies. It's brilliant. Customers seem to like it. So how does it actually work? This is in a Visualforce page. So Visualforce obviously only runs on Salesforce. So Salesforce, we load the Visualforce page, and this is it. It's just a blank page. You can't see that tab up there, but it actually says map. So this is what we load down initially. It's just pretty much up to the user. It's a blank page. Then some JavaScript runs on the page when it loads, and it loads a map. I've got the JS in the corner, so this is loaded by JavaScript. Okay, that's pretty good. Now what do we want to do? That's nice, but I could have just gone to Google Maps to get that. We want to get some data out of Salesforce. So we call back in to Salesforce using one of these 3 techniques we've got here. We've got JavaScript Remoting, Remote Objects, and REST. And we're going to cover Remoting and REST. Remote Objects is reasonably new. It's got some very limited use cases. It's got some big problems in the fact that it's not transactional, but it's very good for very simple CRUD kind of operations. I'm surprised it's not in this workshop, but remoting I personally think is the best, followed by REST and remote objects. So we pull some data back, we get the data back, and then we can render it, because we've got that data in JavaScript, so we can do whatever we like with it, and we render it onto the page. We add these markers onto the page. So this is going to be, it's not the first lab, but this is what we're going to build out this bit here. As you can see, this is what you're going to build. This is the application with the maps. And then just to highlight on the right-hand side there that it works across all devices as well. If you write it right, then it will be very responsive. So we've actually got the same information. It's the same page and the same code running here, both in Visualforce on the desktop and then in Salesforce1 Mobile. There's a couple of little caveats around that, but it means we can use the same code in both places. Excuse me. Right. JavaScript Remoting. It does everything I've just said, really. It's very fast and very efficient. One of the problems with Visualforce is it has a huge amount of view state. View states, everybody understand the concept of view state? So if you load a page and then you go and call back into a class in Apex, that class hasn't just been sat around on the server. It's passed all of its information down to the desktop. And then it all gets passed back up, so it can reinstantiate all your variables, so it looks like you never left. and you're still in the same instance and still in the same instantiation of that class. That's quite data intensive. And all of the controls, they all have their own view state to make sure they can be managed and they can be re-rendered. And that is it's a very heavy and chatty conversation. JavaScript Remoting removes all of that. It calls directly into your Apex class into a static method. And because it's static, it doesn't need to know about anything. So you never get any view state. So it's one thing to remember when you're doing this. It means that the page can operate completely by itself. And you don't have to keep reloading the whole page. And we saw in that example previously, we just pulled the hotel location data back. We didn't really load the whole page. And at the same time, it also maintains security. So it maintains sharing rules and field level security because you're operating within the user's context. So how do we actually go about writing this? So there's kind of three main parts. We need, in our Apex class, in our controller class, we've got to have a method, a static method that's got the @remote_action annotation on it. We'll see that in a moment. Then in the Visualforce page, we're going to have some JavaScript that actually makes a call into that, and then a little bit more JavaScript that handles the result and the response back, be it good or bad. And we'll just run through those three pieces. This is the server side. So this is our Apex controller. We've got a hotel remoter controller. You can see that in here we've got a method called findAll. It's going to return us a list of hotels. Probably wouldn't do this in real life, but it's a good example for now. It's a static method, and it's annotated with remote action. You can see the @remote_action at the top. That's what tells Visualforce and the Visualforce engine that this is a way to call back into us, and it will generate some JavaScript for us. And all we're going to do here is a quick query and return the set results. You'll notice it was global. It was global because we want it to work in Salesforce1. You can have public-only remote actions, but they'll only work within your Visualforce page. If you want to work within Salesforce1, the mobile app, then the parent's disconnected. It's cross-domain and outside of the application boundary, so it has to be a global thing so you can see it across the package. And the with sharing keyword, do we all understand with sharing and without sharing in Apex? No? Okay. With sharing, when Apex executes, it executes in the system context. The system context, by default, by default, it executes in the system context. System context has access to everything. Has access to all rows of data, all fields of data, just completely ignores any security or sharing you have in place. You can add with sharing to the top of your class, and then it will make sure that it obeys those rules. So it will only bring back the rows of data you're allowed to see. One thing to remember is it doesn't help you with field level security. So it'll always bring back, it still has access to all fields. You have to implement field level security yourself in the Apex. Without sharing, you can have a without sharing on your class as well, which reverts it back to the system context. So you'll often find one of the best practices is generally to have all your code with sharing. But maybe if you need to circumvent the rules, you'll have another class that has a utility method in it that has without sharing, so it's only that one small segment of code, so it just overrides where you currently are. So that's without sharing and with sharing. Basically, add with sharing to all your classes, otherwise you'll fail your security review, unless you've got a very good reason to be ignoring the security model. So then JavaScript Remoting, so this is back in the Visualforce page now, so these are steps 2 and 3. So in the green piece here, we can see we've got Visualforce.remoting.manager.invokeAction. So this is a method provided for us by Salesforce that says, I'm going to make a remote action call back into my controller. We then provide this string, which is the name of the method we're trying to call. This string is best built this way using the global variable in the binding, Visualforce binding here. What that will do for you, you can write the name in if you like by hand, but this will manage namespaces for you. So it knows when to add a namespace, when not to add a namespace. It's cleaner, it's a lot more robust. When this first came out, there was a lot of problems with namespaces, and this works around it, so this is the best way to do this. So then we pass that name into the invoke action. We also pass in an anonymous function which takes a result and event. And this is what we're going to implement to handle the callback. So we call invoke action, it goes off, it invokes the action, we get into our Apex that we've just seen, does the query, it does a return. It doesn't know where it's returned to, it just does a return. And then this anonymous function here in JavaScript gets called. We get two things back. We get result and event. Event basically tells us whether it's succeeded or failed. Tells us a couple of other bits and pieces, but it's the most important thing here. And then result contains, it gets returned as JSON, but it gets deserialized into a JavaScript object. So you actually get a list here, as you can see, result length, because that's what we returned. We returned a list of hotel objects that we can just loop through and access the fields that we queried. And in this case, we go through them, and we just call this add marker function, which displays everything on the page. Oh. OK, goodness me, how have I got this far through? Right. My slides are wrong. I do apologize. So I'm going to stop there and actually just run back because I've just merrily bowled on. I do apologize. I get excited about remoting. I've been doing it for the past few months, and it's good fun. I'm pretty sure. Have anybody seen me? Did it say lab 1 or 2 on any of these slides at any point? Ah, there we go. So I was giving you time to sign up. So we've all signed up, yes, and in the book, the bit.ly link, has everybody got, if I bring that link back up, labs 1 and 2, basically, lab 1 is set up an org, which you've all done. Lab 2 is install the package. So if you could just run through those quickly, and then we'll jump back on. So if anybody has any problems with that, let me know, and I'll just bring up this link again as well for the workbook. I do apologize. There we go. For those of you that missed this earlier. So we'll have a few minutes to do this. Any problems, stick your hand up, and I'll come and help. Yeah, there we go already. Look at that. Do you want me to come down, or is it just a question? Sorry? OK, cool. So we've caught up to where we should have been, I guess. Everybody happy with 1 and 2, installing the package, getting the data in? You've had a look at the data model. It all kind of makes sense. Yep, there's nothing unusual in there. Cool. So I rushed through JavaScript Remoting at the same time because it just all flows so beautifully. So I'm going to take a couple of minutes. Anybody, now you've had a little bit of time to listen to what I was saying and kind of go and take the slides in, anybody got any questions around that? Does it make sense as a principle? Kind of, do you see how the 3 composite parts of it hang together? Yeah? Happy with the security stuff? And how it's working within Visualforce, and we can't use it anywhere else because we've got a bind in and all that kind of stuff. Brilliant. OK. Too easy. We might get to testing at this rate. I want to just touch on remote objects while we're here then. So the idea of remote objects is that you can reference objects, standard Salesforce objects, directly in your JavaScript. So you can create an object, and the syntax like new account, name equals Simon Goodyear, and then do an insert on it, as if you would do in Apex. You can only do CRUD operations on it, so you can only do create, read, update, and delete. You can't do anything more complicated than that. But you can, does mean you can pull objects down, you can update them in your JavaScript, and you can go on and go on and go on, and then you can push it up. I mentioned before, though, there are problems with transactions around it. So you can only update one object at a time. So you make one call, and it goes up and it does something, and then it comes back. So the classic example is always account and contact creation. In Apex, you'd create an account, and then you'd create a contact. So you'd create an account, and you'd do an insert. Then you create a contact and reference that account, and then do an insert. That's all done in one Apex method. So if the contact insert fails for some reason, for a validation rule or something like that, it will roll everything back. It will roll back, and it will undo the insert for the account. So you're not left with all this data hanging around. The problem with remote objects in JavaScript is to get the ID of the account to be able to put into the contact, you have to call into Salesforce. You have to say, do the insert, and it comes back with the ID, which you then can put into your contact. And then you call again back into Salesforce. So if that insert fails that time, it doesn't know anything about the creation of the account. So it won't roll that back automatically for you. So transaction management using remote objects, as it stands at the moment, you've got to manage yourself. So it's very, very fast and very, very lightweight if you're just trying to create rows or update simple records. But anything more complicated than that, then stick to remoting or REST, because you actually then execute your code within the Apex context where you get hold of transactional management. Make sense? Happy with that? They're good, and they're very fast, but they've got limited use. So JavaScript and CSS, how do we actually put them into our code? We've seen there the previous slide. This JavaScript is just a script tag in our Visualforce page. Visualforce just is HTML, really. It kind of renders this HTML, so we can put HTML tags in it. This is just an inline script. We all know that's not particularly best practice. So how can we reference external scripts? Well, as I say, again, we just treat it as if it's HTML. So in the example that we've looked at with the hotels and the map, we actually call out to the Google API to get the mapping API JavaScript. And we can just call it as normal source, normal script tag with a sort of remote source on it. That's one way of doing it. That's externally hosted. We can also host things in Salesforce itself. So we can host static resources. Does everybody use static resources in development? Yep, some people, cool. So static resources are a bit of a pain to handle unless you're using something like Maven's Mate to handle the bundling for you. But you can upload individual files as a resource. So you could just upload a JavaScript file by itself, but that gets a bit unwieldy and a bit unmanageable. Or you can upload a zip file of all your resources together and then reference that static resource and then a path within your zip file, and it figures it all out for you. It just keeps things nice and tidy. We reference back to these assets using special tags. So there is Apex include script and Apex include style sheet, which we'll have a look at a little bit later on to include these static resources. But it's how we put resources into Salesforce rather than externally. You don't want to write an application and have to host all your JavaScript somewhere else. It doesn't make much sense. And now you can see why I panicked about not doing lab 1 and 2, because here's lab 3. What we're going to do, so we've seen that as an example. We keep talking about the hotels and the map. What we're going to do in lab 3 is we're going to get you to actually write it. So we're going to get you to build the Visualforce page and the JavaScript and the remote action and understand how it all hangs together. Hopefully, everything that we've just done or we've just seen in the previous slides will all come together now. You've seen all the code. Let's actually just write it and see how it hangs together and how it executes, how we debug it. So if you want to crack on with this one and stick hands up if you've got any problems, and I'll have a wander around and help anybody. Guys, I've just noticed a few people haven't started with a clean developer org, and some of you have got namespaces in them, which is obviously causing problems. It's not returning data because it doesn't recognize the fields, so on and so forth. It is easier to go back, sign up for a clean org, and start again, because you can't remove the namespace. You're going to have to change every code example. That's why we said at the beginning, make sure you've got a clean org. This is the problem. Otherwise, we're going to be spending most of the day editing code samples to include namespaces, and it gets just a bit of a fudge and a pain, to be honest with you, and we don't really learn anything. But if that's what you want to do, feel free to carry on changing all the code and putting your namespace prefixes in. Otherwise, take the 5 minutes it's going to take you now just to run through labs 1 and 2 again with the clean dev org, if you don't mind. Cool. So, sorry that took a little bit longer to get through. Just as well I rushed through everything else in the end. Are we all working? Do we all have data on maps? Yes? Wow, we're excited this morning, aren't we? Scream! It's the first time that anybody's ever screamed when I've said that, so that's good. If you're really bored and you want to tell everybody how much fun you're having, you can always tweet about it. And honestly, tell them you're learning stuff. They'll be so jealous. Have we learned anything? Have we learned anything from that? I think, anybody? Yeah? Yeah? Anything in particular stand out from actually doing it? Namespaces are a pain in packages, perhaps? Yeah? When I say please use a clean developer, anyway. Okay. So we're pulling the data back. We can see how that works. It makes a lot of sense. One thing that did come up, actually, is around API limits. So it was a good question asked earlier. JavaScript remoting and remote objects do not count against your Salesforce API limits. They are free. You can call them as many times as you like. Obviously, the code that you execute in the Apex is subject to all normal governor limits, but actually making the call is free. So you won't chew through your API calls. Using REST is different. Obviously, REST is the public-facing API, and that will use up your API calls. So just want to note that changed. When they first, believe it or not, when they first released JavaScript Remoting, it counted against your API calls, and it upset a lot of people because it can become quite chatty. Brilliant. So hopefully everybody is well on the way to having data on the map. Most people are there. We're going to talk about REST APIs and what they are. Everybody understand REST as a principle? Do we know what it stands for? Go on, somebody. I know you want to put your hand up and say it. Okay. Fair enough, I won't tell you. Representative state transfer. So it makes use of the verbs in HTML to describe what you're doing at that URL. So you have a URL, which is your endpoint, and then get is going to retrieve data, post is going to push data, so on and so forth. Delete, and I can't remember what I've never remembered, but patch is like an update. So it makes use of the you keep one URL, so it's a constant endpoint, and it makes use of the verbs. It's just a nice way to transfer data around. Often JSON, but can be anything. So when would we use the Salesforce REST APIs, especially given the fact that I've just told you they chew up API calls? They don't sound like a particularly good option. Basically, it's when you want to connect to Salesforce from outside of Salesforce. So when you want to integrate existing data, generally, from a third-party system or web service or something, you want to push data into Salesforce or pull data out of Salesforce, this is when you start using the REST APIs. Companion or consumer applications, again, it's another way of doing it. So if you're building a mobile app that is just an app, perhaps using the mobile SDK that Salesforce provides, that's obviously not authenticated within Salesforce. It's a standalone application, so you'll make use of the REST APIs. And this magic Internet of Things, it's the same principle. If you want to talk to Salesforce, use REST. It's not authenticated. So when you want to connect from something that isn't within Salesforce, that isn't got Salesforce authentication, all that kind of stuff around it, use REST. The others just won't work. Remote objects and JavaScript remoting just won't work. There are the standard REST APIs that come with Salesforce, give you CRUD actions. You can also write your own REST APIs. You can write Apex code and then expose it really easily as a REST API. You don't have to do anything apart from put an annotation in again. So it's very, very straightforward to do. So as I say, if you are building a mobile application and you want to pull some data out of Salesforce, here we've got an example of a mobile app that's being built using the mobile SDK. This isn't Salesforce1. Don't think of Salesforce1 at this point. Salesforce1 is its own application, its own container, and it's authenticated within the Salesforce ecosystem, so you can use the other bits and pieces that we've just been talking about. This is an application that you've built yourself. There was a great Elevate session on this before about how to build these applications, hybrid applications, so on and so forth. But what we're doing is we are using the REST API to call into Salesforce to pull Salesforce data back. And then we're displaying it, because everybody wants to see your product catalog on their phone. And this is how you do it. We OAuth first. OAuth, is everybody happy with OAuth? The principles of OAuth, the idea of OAuth? The OAuth dance, as it's called. Hands? Just so I've got a rough idea, because it's vaguely useful. Okay. If you're not, have a quick read of it. It's the de facto way these days to authenticate. You essentially request permission from Salesforce. So you log into Salesforce, you force the user to log into Salesforce at a Salesforce URL, and then what you get given back as an application provider is a token that says this person has access to that data, and they can do it. And you can control what profiles they have in terms of what data they can access and what things they can provide. You know, everybody's using Facebook, Twitter, everybody uses OAuth. You know, when you go and say, I let this person play this game, that kind of thing. It's connecting via OAuth at that point. So we get a token back, which we can then put into our header, into our HTTP header when we make our call out to Salesforce in a REST API. And that says this person can or can't see that data, they can or can't do this action, and then returns either the data or an exception. It's pretty straightforward. There are, however, some issues with it. So if we have our application hosted in Heroku, and we want to view data that's in Salesforce, those two things are happening in different places. So we're going to run into cross-origin restrictions. So cross-origin restrictions are in place to make sure people can't attack you by putting a bit of script on that then redirects all your data across to some other website that they then use your Fluffy Bunny 69 password to go and access all your bank accounts and that kind of stuff. So your application is served up from Heroku. You do your OAuth with Salesforce, that's fine. There's nothing to worry about that because that's HTML, so we're all in control of this. It's user-initiated. Then we try and make a call using some REST APIs, so in some JavaScript. And it's at this point in the JavaScript, when we're calling the REST API, that we're going to say it can't happen because the call we're making back to, so we've got a page, our index.html is served from our Heroku server, and from that we're trying to make a JavaScript call out to Salesforce. So it's not calling back to where it came from, and the browsers don't like that. We can work around it, though. We can work around it by putting a proxy into our application. So it's the same kind of idea. We serve up our application. We've got our index and our app. We do our OAuth to get our token. Remember, there's nothing wrong with that. We're just calling an HTML page. We're returning an OAuth token. We've got this data back now. And rather than calling to Salesforce with that token to get the REST API and the data back out, we call into the proxy. That's OK, because we're now calling back to the same point, and the browser's happy with that. The fact that we proxy it off and go somewhere else, that's our responsibility. The browser's happy with that because we serve the page so we know what we're doing when we get the call back. That's the theory. If somebody compromises your server, then obviously that's problematic. But so this is the data moving back and forth. Excuse me. An example of this kind of proxy in application, if you can try this one, if you can see that bit.ly link there, try Sockle. So just a quick explorer in Heroku. So if you want to spin this up and have a go with it, you'll experience the OAuth flow with Salesforce. You've probably seen it before. What's going to happen, you're going to go here, and it's going to ask you to, if you click the login button at the top right. Actually, if you don't click the login button, it will return you an error when you hit run query. But if you click the login button at the top right, it's going to initiate that OAuth dance. It's going to initiate that OAuth sequence. It's going to open up a page in Salesforce, and you're going to log into Salesforce. But you'll never get to Salesforce. That page will then close and return a token back to this Heroku app here. And it will then use that Heroku token to pass data back to Heroku to the proxy, then into Salesforce and back down. So if you want to have a quick play with that and just see what that looks like and feels like with an application that's working, because you're going to build one in a minute, so it's nice to see where you're aiming for. OK, cool. While you're doing that, I'll have a look at this page. This is how you set up. This is how you configure a connected application to allow that OAuth connection in Salesforce. It looks more complicated than it is. There's only actually about 4 or 5 mandatory fields here. The interesting thing with a connected application is once you create one in your Salesforce org, anybody can then use it. It doesn't have to necessarily just be users in that org. It can be people everywhere. This is just like a reference record that it'll always come back to. You're going to get a token back out of it. All this is saying in here is this is the name of the application. We have this thing called a callback URL. This is where we're going to call back to. This is where we're going to hand our token. Once we've logged in, we've done the login screen. You've probably just all done that. It calls back into the Heroku application with the token, and you're going to save that token. Yep. I can't easily, I'm afraid. It's stuck image. You're gonna do it in a minute anyway. So you'll just trust me on these fields. So the callback URL is down here at the bottom. Just like not the big one, but the one above that. That's the URL we're going to call back into. It's going to hand the token back in. That's up to us to process that token and store it in our external application. And then the scope at the bottom is basically saying what can somebody with one of these tokens do? And you've got lots of different options. In this particular case, we just go for full access because it's easier to deal with. That's how you configure a connected app. Again, don't worry too much about this. You'll do it in a minute. The Force.com REST Toolkit. I'm not too sure why they put this in here, to be honest with you. This is useful, but we're not going to make use of it right now. The REST Toolkit, what Salesforce have done for you is they've created a JavaScript library which wraps up a lot of the handling of the OAuth token, the refreshing of the OAuth token, and the calls out, and just makes it a lot more JavaScript friendly rather than just being a raw API that then you have to code on. So it's worth noting. I think it used to be called Force TK, if that makes any sense to anybody. Right. Pretty sure it's not supposed to say Lab 10. Whichever the next one is, 4, I believe, using the REST APIs. What we're going to do is we're going to build an application now that is external to Salesforce. So we're going to have to do the OAuth, and we're going to then call in using REST APIs to pull data back out. And we're going to mock it up and make it look a bit like a mobile application because everything's mobile. We love mobile. So yeah, if you could have a dig at that and kind of 15 minutes or so, and stick your hand up if you've got any questions. "15 minutes. I lied. It's not that complicated. Try 5 or 10 minutes. Yep, sure. In step 1, it says, download this zip or clone the repository. Don't clone the repository. It all points to the wrong place. Download the zip. Completely forgot about that. Sorry. That's okay. The other thing with this is a successful result of this is a blank page, helpfully. And if you are already logged into your org, which I'm guessing you probably are, you're already authenticated, so it will pick up a cookie and it won't do anything. It will just, when you load the URL, it will just load a blank page. So the best thing to do is log out of the development org that you're currently in, and then reload localhost 3000, and you should go into the OAuth flow. Cool. Cheers, Tom. Okay, it doesn't actually say. Windows users that have never installed Node before, after you've installed it, you need to add the directory to your path. Otherwise, when you try and do Node server, it complains. I haven't used a Windows machine in years. I can't remember how to add it to a path. How many Windows users do we have? Can you all leave? Has everybody got it? I know you haven't. I'll come and help you. Has everybody got it set up or not? Node working on Windows? Put your hand up if you haven't. 1, 2, 3. Right. Can anybody remember how to add a path variable? It doesn't always in Windows. That's the problem. Need a path setting up. Thank you, Chris. This is apparently how we do it. At the command prompt, if you can enter that, that should then work. It's set path, is it? Yeah, if you put it in the environment settings, then yeah. But for now, maybe just to push through this, if that's all right. What do I need to make that say? That's fine, is it? It's not my fault. I don't do command prompts anymore. Cheers, thank you. Folks, how are we going with that one? We've got Node installed and running. Yeah, just generally on this one. You might just have to keep working at it, otherwise I don't think we're going to get to the end. A couple of problems? Questions, problems? Okay, wait a second. I'll go around and do a quick lot of questions again and then we'll get going. In the interests of getting vaguely towards the end of this, we're just going to quickly push on if that's all right. Most people have got that running, that auth stuff, is that right? And there's a couple of people that don't, and I'll come around and answer questions again in a minute, but we'll just keep going. So we're going to have a look at static resources now, how we move this out of being inline and kind of reference static pages. So we've talked briefly about what static resources are already. You already all know what they are. They're things that we need to make the page work, JavaScript files, CSS files, images, so on and so forth. And as I said before, we can upload them individually or as a zip or a jar file and then reference into that file. And we'll have a quick look at how that works. Just in case you've never seen a static resource before, this is what it looks like. Once you've uploaded it, you'll find this in the setup menu under develop and static resources. Let's give you a list of them. You can see the first one there, assets, is a zip file, and then jQuery is just a JavaScript file. So we've got a good mix of things there. So how do we actually reference these? When you do Apex page, the Visualforce rendering engine automatically generates the HTML, the head, and the body tags for you. It knows where to put them. And if you then use the Apex style sheet and include script tags, it will figure out, you can put those anywhere on your page, and because it's generating the HTML, the head, and the body tags, it will strip them out and put them in the right places for you. So, well, I say right places, it'll move everything into the head. You don't necessarily always want it there, admittedly. Most times you do. I'm rambling. It just tidies it all up for you and manages it. It's an easy way to do it. To actually make use of these, this is how we do this. Everybody's familiar with the dollar notation and the binding notation, the exclamation mark, curly braces, and Visualforce, yeah, I presume. So to reference a single file, it's pretty easy. You just say resource.filename that you uploaded. So not file name, the name that you gave to the static resource. It's not necessarily the file name. And then that will pull that back, and it will include the script. It will generate a script tag or a CSS style sheet tag or whatever you need it, or an image and tag. If you've uploaded an archive, a zip file or a jar, which is a nice way to consolidate all your resources into one thing, then you need to just use a slightly more complex syntax and make use of URL4. URL4 basically says, get me the URL for this asset, for this particular resource. Actually, it's this asset. So we're in resource.assets, which we saw before. It's the zip file. So we're saying, go to this zip file, and then, once in that zip file, navigate to this directory. So for the style sheet, we'll go into the CSS directory and pull out that file. And what that will do for you is it will generate the URL that's got the right static resource name in it and the random, apparently, or period, or kind of random number, which is just a timestamp to make sure we always keep the latest version running. But it will do all that for you. So resources can be moved around, and Salesforce generates new URLs, but this will always make sure you get to the right place. You can override the default behavior of Apex page. You can tell it not to generate a HTML tag, or indeed not to generate a body tag. If you tell it not to generate a body tag, it also doesn't generate a head tag. Just put that one out there. And you can't tell it to generate a body, but not a HTML. One requires the other. If you do that, then you should include the HTML tags and the body tags and the head tags in your Visualforce page within the Apex page tags yourself. So you should just like building a whole HTML file in there rather than just the pieces of it. We can also make use of the HTML hyphen prefix to an attribute. And what this says to the Visualforce engine is pass this tag through to the HTML that you generate. If you don't put that on and you try and use a custom attribute on a HTML element, Visualforce just won't compile it, throws an error and says, this is not a valid tag. So, but if you prefix it with HTML hyphen, then you can push all sorts of attributes through. And that then lets you do some of the more funky things in HTML5, like ghost text and so on and so forth. It's also useful when you're building Angular apps. And if you don't want to let Salesforce generate your resource URLs, then you can just use standard link and script tags. I wouldn't recommend it if you're using static resources because the URLs are complex and difficult to figure out and change as soon as you upload a new resource because it's got a timestamp in it. So if you're using an external source, this is probably the easiest way of doing it, but if you're using a static resource, make sure you use the previous tags. And here you go. This is a similar kind of thing. This is just using the standard HTML tags. It's exactly the same syntax as before. We can point directly to a file, or we can point to a file within a zip file. All that's doing is it's generating a string. So you can put those bindings anywhere. You know that in Visualforce anyway. So. And that leads us to lab 11, which isn't 11. I've lost count. It's probably 5. Which we'll look at using these static resources. We're going to build a very similar page to the one we just had. Actually, we're going to build on the application we've had. So we've done the authentication. We're now going to build the application that's hosted in a Visualforce page using some static resources. So if you want to crack on with that, it's 11 o'clock, so we're kind of pushing time. I'm very keen to get through this one and through Canvas. So I might just keep going and come around and answer questions as I can. We might have a little bit of time at the end as well. But if you want to get going with exercise 4, then that'd be great. I'll come and answer the questions about the other stuff.